Continuing on with our real-world system of equations assignment, look through 4, make sure you notice all the important information on there. This one's not quite as complicated as the previous one. What variables we should use should be fairly clear because we're trying to figure out how many of each item, and they're not being put in boxes, it's just calories and whatnot. So, real quick, this one should be 2,500, not 2,200, sorry about that. And let's use C to be the number of cheeseburgers, and we'll let F be the number of French fries. So now we have our variables established. We want the number of cheeseburgers, number of French fries. We can actually take our information from this situation and figure out to get us more to get us our system. So look for a total. I recommend starting with that. Our total is the 2,500 calories, and the way you're going to get 2,500 calories is by eating some cheeseburgers and French fries. Well, how many calories do you get from a cheeseburger? You need to take that number and times by the number of cheeseburgers you eat. So 500C, 500 times C, and you have to take the number of calories per small fry order and times that by you have to take 200 and times by the number of small fry, and that gives you the calories from the French fries. So here's my first equation. My second one is going to come from another statement, and that's from this one. You got 2 more small fries than cheeseburgers. So to figure out your number of French fry orders, you need to take your number of cheeseburgers and add 2. So I just translated that statement into that equation there. So now I actually have my system, and I'm ready to go. Okay, so I just copied my system over here, and I noticed already my system's already set up for substitution because F is C plus 2. So I'm going to sub that into my first equation, 200, instead of F, it's going to be C plus 2. And then plus 500, C is going to equal 2,500. And to solve this one, to combine like terms and whatnot, I need to distribute that 200, so I'm going to get 200C plus 400. Plus that 500C is going to equal 2,500. I need to now get rid of that 400, just get the C's all by themselves on the left side, and while we're at it, we'll combine the C's, 200C and 500C, add together to make 700C. 700 times the number of cheeseburgers is going to equal 2,100. And so we need to get C by itself, divide both sides by 700. You'll get C equals 3. Ta-da! Just like that. And since C is 3, we can take what C is and plug it into that equation there. F is just equal to C, or 3, plus 2. So F is going to equal 5. And there we go. That one's all done, ready to go. Let's move on to the other one. So read it close, make sure you glean out the important information. Okay, so as you read through that, make sure you notice what your numbers are, what variables we should use. And notice how they're both, like, one's birthday cards, the other one's candles. We probably don't want to use C for both. Let's use B for the number of birthday cards, and we'll let C be the number of candles. So now we have that established. Look for totals, or some sort of relationship between the numbers. Here I notice I have a total of $861. So whatever makes up that $861 is going to equal it. And notice that the cost, or the money they get from each, is just going to be 5 and 12. So if you want to get the money from birthday cards, you have to take 5 and times by the number of birthday cards. And you should add that to 12 times the number of candles. So that's why it's 12C, $12 per candle. And if you add that up, you're going to get your total of $861. And this statement here is selling 3 times as many candles as cards. So if you want to figure out the number of candles, that would be 3 times the number of birthday cards, or C equals 3B. So here's our system. We have 2 equations with 2 unknowns, and we're ready to go. This one's already set up for substitution because C is 3B. So I can just take 3B and put it where C is. And now I got my new equation of 5B plus 12 times 3B equals 861. Still equals 861 as I do a little bit of calculating. 5B plus 36b, because 3 times 12 is 36. And I'm going to combine those to give me 41b equals 861. I just need to divide both sides by 41 to get my b all by itself. I don't particularly know that off the top of the head, so use a calculator. It'll probably be helpful. 861 divided by 41 is going to give me 21. So it's looking like 21 birthday cards. And since I know that b is 21, I can substitute it back into my other equation. C is equal to 3 times b, which is 21. And so C is going to equal 63. So 63 candles and 21 birthday cards. And that one's done. Let's move on to 6. Read through it. Make sure you notice all the different important things. And also notice what variables you're going to use, what sort of things you're counting and you're trying to figure out. In this particular one, we're trying to figure out the number of boxes of Myconix and how many vampire books you got. And so let's use M for the number of boxes of Myconix, and let's use B to equal the number of let's use V, because we've done B a lot. V equals the number of vampire books. So there you go. Here's our two variables. Now we need to set up some equations using them. I recommend looking for some sort of total, and she kind of blew all her money. And so she spent $221. So that's going to be my first total. I'm going to get 221. And you get that total from the cost of the box of Myconix and the vampire books. So if you take the number of boxes of Myconix and you times it by 2, that's the cost of the Myconix. And if you take the number of vampire books and you times that by 9, that's going to be the cost of the vampire books. So if you take the cost of the Myconix and the cost of the vampire books, and you add them up, you'll get $221 because you used all the money on those. Another statement that gives us an equation is going through 4 boxes of Myconix for every vampire book. And so the number of boxes of Myconix is going to equal 4 times the number of vampire books. Not the other way, right? The vampire books are not equal to 4 times the number of boxes of Myconix. That'd be like a fourth of a box per book. You have to make sure you switch it out. So anyway, there's our system. We can use it to solve this. Alright, so now we have this. Let's solve the system. And I'm going to do substitution again because M is just 4V. So I'm going to take that 4V and put it where M is in my other equation. So I'm going to have 2 times 4V plus 9V is going to equal 221. Well, 2 times 4 is just 8, so I have 8V plus 9V equals 221. We'll combine those to make us 17V equals 221. And you just need to divide both sides by 17 to get V equals, well, 221 divided by 17 is 13. So the number of vampire books is 13. So if we want to get the number of boxes of Myconix, we're going to take 13, put it back into our equation there to get M equals 4 times 13. Well, 4 times 13 is just going to be 52. So poor is it Katie? I think it's Katie. Katie had 52 boxes of Myconix and 13 vampire books. And we could probably do another one on this video. Let's do 7. Read it close, look for what you want your variables to be, and some totals. Okay, so typically some good ideas of trying to figure out what variables you're going to use is figure out what the question's asking, because once you get your answer, you're done. You don't have to do that little debacle we did on, 2, 3 with the books. Anyway, so if we want to figure out the number of students a van can carry, let's have V equal the number of vans, and let B equal the number of buses. I want to do a little bit of finagling to make sure we get the number of students that go in each, but this will help us out in just using the numbers, because V will be vans, B will be buses. So with this, we can actually just take these sentences and use them to write equations. So school A did 1 van, or just V, and then 6 buses, so 6B, and it came out to be 372 students. So 6 times the number of buses. Oh no, this is probably not right. Hopefully you notice the quick change that I made to what my variables mean. V is going to be the number of students in a van, and B will be the number of students in a bus, because our information we have are totals of students, so we should have V and B represent number of students. So if you take a van full of students and you add 6 times the number of students in a bus, that would be the total number of students in 6 buses in one van. And our other equation is going to come from this next statement, which is 4 vans, or 4 times the number of students in vans, and 12 buses. That's a lot of buses. 12 times the number of buses is 12 times the number of students in buses. It's going to give us this. So this is our system, and we just need to solve it now. So copy my system over, and I'm going to go for elimination this time, because I noticed that 6 and 12 are just multiples of each other. So if I take this first equation and times by -2, I'll get -2v, -12b, and 372, -744. I can actually now add these equations to get rid of the b's. They'll add out. So 4v plus -2v is going to give me 2v. And on the right side, 780 plus 744, well, -74, it's going to give me 36. And I just need to divide both sides by 2 to get v equals half of 36, which is 18. And now I know what v is, and at least the number of students in a van. And I can take 18 and plug that actually into, I'm going to put it into this first equation that I had there originally, because that's going to give me 18 plus 6 times the number of students in buses is going to equal 372. I just need to subtract the 18 and divide by the 6. 6b equals 372 minus 1. 8. 354. And divide both sides by 6. And that'll give you how many students fit in a bus. 354 divided by 6 is going to give me 59. So there we go. Number of students in vans, number of students that fit in a van 18, number of students that fit in a bus is 59.